From Uranus onwards to Neptune. Some 3 billion miles away from Earth, the probe would have to take a very precise trajectory over the North Pole of the planet to get the best possible view of Neptune and its large moon, Triton.
The challenge at Neptune was the most difficult one we'd had. We had to know within 1 second when we were going to fly over the North Pole of Neptune. That was a major navigational challenge. We had never delivered that kind of accuracy before, and if we were right, it worked, and if we were wrong, we had no second chance.
After 12 years in flight, Voyager arrived at Neptune. Brad Smith and his team feared after the bland face of Uranus that they would see little when they got to the last giant. They need not have worried.
Is that a rugged surface or what? I don't know what.
The final encounter I was able to witness here at JPL with my youngest son, and we watched with fascination as the pictures of Neptune unfolded. Suddenly, things that no one had imagined were there. Here was a planet that was vibrant with life. It had its own great spot, a dark spot in this case, white clouds floating in its atmosphere, and these things unfolded before our very eyes, and what a wonderful surprise. Neptune, for me, was a great surprise.
There was something strange and eerie about Neptune, because here, the last planet, you know, the sentinel at the outer edge of our solar system, looks like Earth, with its beautiful deep blue color and its white clouds floating in the atmosphere.
We were back with a really exciting planet again at Neptune. There were fast-moving clouds that moved in different directions, some of them almost at sonic speeds. The complexity of the planet's atmosphere was far beyond our expectations.
Neptune turned out to have the strongest winds of all. Here in the furthest extremes of the solar system, where the sun barely penetrates, the last giant defied all expectations.
You might expect that the further you got from the sun, where there was less energy to drive the winds would be slower. The winds on Jupiter were already hundreds of miles per hour. It turned out, rather than seeing slower winds, we found faster winds. We found winds over 1,000 miles per hour at Neptune. We now understand why that's the case, and that is, if you have enough energy, it creates a lot of turbulence, and that slows the wind down. At Neptune, there was so little energy that the wind basically got started and would just go and go and go.
Neptune's atmosphere was much more dynamic than Uranus, but it was made of the same gases and ices. The last two giants were very different from their more massive cousins. Uranus and Neptune are not gas giants, but ice giants. From Earth, nobody had seen a full set of rings at Neptune. But some scientists believed they had seen incomplete segments of a ring, which they called arcs.
By the time we got to Neptune, I was leading the small group of individuals on the imaging team who were responsible for the rings and the ring arcs. In fact, there were some people on the Voyager imaging team who just completely doubted the existence of these things. They thought we were crazy. They thought we were wasting precious spacecraft resources. And so it was very gratifying to finally see that one image come down where we finally caught them in the act, the Neptune ring arcs. So it was a tremendous achievement.
Neptune is indeed surrounded by ring arcs. How they got there, and why the ring is incomplete, is not yet understood. The impossible mission was almost over. Neptune's moon Triton was the final encounter.
Triton is a large moon. It's about the same size as the planet Pluto, actually. So if it were out in orbit around the sun, we would call it a planet. But it's in orbit around Neptune. But unlike all the other satellites which orbit in the same direction as the planet rotates, Triton is in a retrograde orbit. It's going around Neptune backwards, which told us it was not likely formed around Neptune, but had been captured by Neptune.
Triton is a moon that might have been a planet. But it strayed too close to Neptune and was caught by its gravity. Triton turned out to be one of the strangest worlds encountered.
This is too much. This is much to believe.
Oh, God. Look at the tire tracks.
Yeah, right. There you go. Big buggies.
Triton was a world unlike any we had seen before. It was the coldest surface we'd seen in the solar system, 40 degrees above absolute zero. So cold that nitrogen, which forms most of the atmosphere on Earth, is frozen solid ice. And the polar caps on Triton are frozen nitrogen, not frozen water. Even so, we found geysers on the surface of Triton. Nitrogen geysers miles high. So even in the very deepest part of our solar system, there is geologic activity. It is everywhere. The solar system is alive, evolving, and that's what makes it so exciting and makes it so much to learn.